So today we're starting Unit 5. The first topic of Unit 5 is graphing rational functions. Okay, so we have our equation of a rational function, y equals 1 over x. We're going to use a table of values to put into the equation to find out points we can use to plot the graph. Okay, we're also going to find 6 pieces of information from the x-intercept to the range are on the left that we're going to use to help explain what's going on in the graph. Okay, so let's look at the table of values. So if we put -4 in for the x value, we'll get -1/4 for the y. If we put -2 in, we're going to get -1/2. -1 gives you -1. Now 0, if you put 1 divided by 0, it's an error on your calculator. This is because you can't divide things in math by 0. Right? It gives you something that's called undefined. So we're going to put down that. Okay, so it's not a point, it's just something's going wrong there that we got to figure out what to do with it. All right, continuing on with our points, so we would divide 1 by 1 and we get 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. Okay, so what we're going to do is we're going to take these points and plot them on our grid. So -4 and -1/4, -2 and -1/2, -1 and -1. On the other side, we got 1, 1, 2, 1/2, 4, 1/4. So those are the points that we're given. This is a strange-looking graph to have these points for, but it's going to make sense because we're going to graph it like this. Just 2 sweeping curves. We go like this. Now this makes a little more sense if we go back and look at the point where it's 0 undefined. Okay? The reason it's undefined again is because you can't divide a number by 0 in math. So what happens is you get something called an asymptote. An asymptote is like an invisible barrier or force field that the graph can never cross. And the vertical asymptote is very serious about this. You can never, ever cross a vertical asymptote. Okay? However, there's another asymptote in this problem. It's a horizontal asymptote. Now, sometimes, in certain situations, given the equation, you can cross a horizontal asymptote. Okay? It again is a barrier. It's a barrier that the graph does not cross. It kind of gives some shape and boundaries to your lines that you're graphing. But again, your vertical asymptote, you can never cross. Horizontals, every once in a while you can. All right. With that being said, let's look at the information on the left. Okay. Let's go through it based off of our graph. So first we have the x-intercept. This is where the graph crossed the x-axis. But looking at our graph, the graph never crossed the x-axis because there's a horizontal asymptote there. So this is none. And that's not to say it's always going to be none. We're going to show you other ways to find it when you're going to get one because your equation's different. For the y-intercept, where the graph crosses the y-axis, again, because there's a vertical asymptote on the y-axis, the graph doesn't cross the y-axis, so this is also none. All right, the vertical asymptote. This is asking you what's the equation of the vertical asymptote. In this case, x equals 0, because it's on the y-axis. For the horizontal asymptote, same idea. What's the equation? Since the horizontal asymptote is on the x-axis, we have y equals 0. Now domain and range. Domain is what values exist for x's in this graph. Okay. So if we go from left to right, we want to know all the x values that exist in this graph. Well, it starts off at -infinity all the way to the left, and it goes until you hit that the vertical asymptote, which is at 0. It's got to jump over 0 itself. Everything else is okay. Start up again on the other side and go to +infinity. Okay, so the reason it's not a bracket on the 2 zeros is because you can't include 0, but you can include everything else except for 0. For the range, the same idea, but this time the y values. What y values exist in this graph? Again, starting at the very bottom, which is at -infinity. We can go up until we hit the horizontal asymptote, which is at 0. Jump over 0. Continue on towards +infinity. Okay, now, this is the simplest version of our equation and graph, and there are going to be more complications if we add pieces to our equations. So let's explain how we can find all of these things to help us graph these equations. Okay, first is the x-intercepts. The x-intercepts is found when you take the numerator and set it equal to 0. Okay, in this case, since we have 1 over x, we take the numerator of 1, set it equal to 0. Well, 1 does not equal 0, so this is not a true statement. This is why there is none for this particular equation. Okay? For the y-intercepts, you put 0 in for the x's. Okay, so our equation is 1 divided by 0, which gives you an undefined, which again is why there is none for this particular equation. Your horizontal asymptote, okay, is found when you take your denominator and set it equal to 0 and solve for whatever it is. So in this case, x. So we have x equals 0. The denominator is x, set it equal to 0, and this turns out to be our equation. Okay. For the horizontal asymptote, this one's a little bit different. You're going to put a really big number in for x. So what that looks like is this. 1 divided by, let's just put a bunch of zeros behind a number. Okay. What happens is 1 divided by a really big number is a number that's really close to 0. And because it's really close to 0, we just say that the equation is y equals 0. Okay. Now, again, things will impact all these different things that we're looking for, and we'll see that in a little bit. Okay, so the domain. Domain is all the values that exist for x. Okay. And the range is the same idea, but just the y. All the values that exist for y. Oh, I forgot an exist. Change that in the notes over here. There we go. All right, sorry about that. All right, so that's basically what I'm going to do. Now, it's going to be hard to kind of like remember all this stuff, so it's really important that you practice these problems so you get used to how these things work, and that's what we're going to do next. Okay? Because we're going to see some changes to our equation. So what we have now is we have an equation of y equals 1 over x minus 2 and then plus 1. Okay, so these are going to be vertical and horizontal shifts, just like we've seen in first semester with some of our equations. We're also going to see vertical stretch and compressions and then horizontal stretch and compressions. Okay, first thing you have to know is where these exist. Okay, so first we have an equation. I've shown you where all the different things are going to be. So we have A, B, C, and D are going to be the changes that can happen to these graphs that we're going to be showing you. First, horizontal shifts. That's when we have something being added or subtracted to our denominator, x. Okay. Now what's going to happen for this is this is going to move left or right, opposite of the sign. So if it's plus, it moves to the left, opposite what you normally think. If it's minus, you move to the right, opposite what you would normally think. Okay? Vertical shift, so you're adding or subtracting something on the outside of your main function. Okay, so this is going to be going up or down. It's going to follow the sign of the number. So if it's plus 1, you go up 1. If it's minus 1, you go down 1. Okay. Now these two you won't see as much, and it won't really make a big difference because it's not going to affect how we do the graph, because we're really going to do is sketching the graph. You have to be aware of what's happening, like is there a vertical stretch or horizontal stretch or compression. So a vertical stretch is going to be when something is multiplied directly on the x. Okay, so that's going to be the stretch or compression. If it's greater than 0, or sorry, if it's greater than 1. So if b is greater than 1, it's a stretch. If b is, actually, let's back up. If b is less than 1, but greater than 0, it's going to be a compression. Okay. And the last part is if there's a number that's replacing the 1, so let's say it's a 3 or a 4 or 5 or whatever, and here it's going to be the reverse of what we just wrote up for the verticals. Okay, if it is greater than 1, say compression, if it's between 1 and 0, it's a stretch. Okay? So, we can see in our problem here with our graph, we have a horizontal shift of -2. That means the graph moves to the right by 2. So normally the asymptote, the vertical asymptote, is on the y-axis, which is at 0. Now you can see the vertical asymptote is moved over by 2 to the right. Okay. Here we have a vertical shift going up by 1. You can see that the horizontal asymptote has been moved up from the x-axis to +1. Okay, so that's how these graphs will change. Now the one thing we haven't shown you here is with those shifts is how do you find the x and the y axis, or the x and y intercept, and that's what we're going to do next. Okay, we've shown you at the top how to do it, but we haven't actually done a problem with it. Okay, so what I would suggest when you're doing these problems is you find these 4 things first. Okay, and you use that information to graph your equation. And then the bottom 2 you do second after you have your equation set up, because it's easier to see where the domain and range are after you have a graph. Okay, so the first thing is to find the x-intercept. Now I said when you find the x-intercept, you're going to take the numerator and set it equal to 0 and solve for x. Well, the issue is you have basically 2 numbers. You have this number and you have this number, and they're both technically fractions. Well, to find the numerator, we have to combine those fractions, which seems like a pain in the butt. I'm going to show you a shortcut. Okay, what you're going to do is you're going to take the numerators of both. You got 1 minus 1. Actually, I'm going to make some space for myself. 1 minus 1. Then on the second number, the -1, you're going to multiply that by the denominator of your first fraction, x plus 6. And you're going to set it equal to 0. Okay, now all we have to do is take this equation and solve it for x. So we have 1 minus x minus 6 equals 0. If we solve for x, we're going to add 6 and subtract 1. Negative x equals 5. Divide by -1, and x will equal -5. That is your x-intercept. Now, because it's an intercept, we want to write it as a point. So -5, 0. Okay? So that is the x-intercept. Again, we're taking the numerators, the 1 and 1, and multiplying it by the second one, by the denominator of the first fraction. Okay, setting that equals 0 and solving for x. For the y-intercept, we're going to put 0 in for the x value. So we have 1 over 0 plus 6 minus 1. And you can use your calculator for this. So you have 1 divided by 6 minus 1. Make that into a fraction using your calculator again, and you get -5 over 6. Again, we want to write this as a point, so it's 0, -5 over 6. All right, so now we found both the x and the y-intercept. Let's graph those. The x-intercept is at -5, 0, which is right there. The y-intercept is 0, -5 over 6. Now people are like, well, how do I graph a fraction? Just kind of guesstimate as best you can. -5 over 6 is close to -1 on the y-axis, so it's about there. Okay, so those are our 2 points that we can find given our problem. Next, the vertical asymptote. Vertical asymptote, again, from the top, when we're going over it, you take your denominator, set it equal to 0, and solve for x. Okay, So now we have x equals -6. In the horizontal asymptote, you have 1 divided by a really big number plus 6, which is going to be just a really big number plus 6. So let's do this. Nope. Which you won't need to do all the time. All right, and then -1. Okay, so what that's really going to do is, this is the number we care about the most when you have a vertical or vertical shift. Okay, the other one's going to be 0, -1, and 0 minus 1 is going to give you -1. Okay, so what we're going to do is graph both the vertical and the horizontal asymptote now. So we have -6 for your vertical and -1 for your horizontal. Okay, so now what we have is we have our boundaries with our 2 points. Graph's going to look something like this. Okay, I know if that's on that corner, that graph's on that corner, the other corner is going to have the other one. And I'm just sketching it, so I don't really need the points for the other one. I can find points if I really wanted to, but I don't. Okay, so that's the graph that you're going to have for this particular equation. The last 2 things is the domain and range, which I think is helpful to have the graph in place before you find these. So the domain, again, is the x values that exist in this graph. So it starts off to the left, far left, at -infinity, and it goes till you hit the vertical asymptote, which is at -6. It jumps over -6, continues on towards infinity. The range, same idea, but this time the y values. So you have -infinity. It goes up until it hits the horizontal asymptote, which is at -1. Jumps over that, starts up again towards positive infinity. Okay. All right, let's try another one. This time we have a a horizontal stretch and compression. But we're not really too worried about that number because we're just looking for the sketch, so we're going to find the information that we did at the last problem and just deal with it. Okay? So our x-intercept, again, we're going to take the numerator. This time we have 3 minus 4, and we're going to multiply that 4 by our denominator of x plus 1. Set it equal to 0. Okay, so we'll have 3 minus 4x minus 4 equals 0. And now we need to solve for x. I'm going to add 4 and subtract 3, which gives me -4x equals 1. Divide by -4, and x will equal -1/4. I'm going to write that as a point for my x-intercept. -1/4, comma 0. For my y-intercept, 3 over 0 plus 1 minus 4. So I have 3 minus 4 is equal to -1. Write that as a point. I'm going to graph both of those. So at -1/4 on the x-axis, it's going to be about there, and -1 is going to be about there for my y-intercept. Okay. Next, my asymptotes. For the vertical, I take the denominator, x plus 1, and set it equal to 0. So I have x equals -1. All right. My horizontal asymptote is 3 divided by a really big number, and then minus 4. Again, I'm going to say really big number. That's ugly on. All right, minus 4. Again, I don't care about this part because it's going to give me 0. This is going to tell me what my horizontal asymptote is going to be. Y equals -4. All right, so let's graph those 2 things. X equals -1 is going to be here. My dashed line. Then y equals -4 is going to be down here. So my graph's going to look something like this. And then I'm going to have another one on the other side. There's a graph there. Okay, so now that I have my graph, I can find the domain and range. So my domain, again, the x values that exist, starting at -infinity, going towards the vertical asymptote, which is -1. Jumps it, starts up again on the other side, towards positive infinity. The range is the y values, starting at negative infinity, going to the horizontal asymptote at negative 4, jumping across that to the other side towards positive infinity. And there we go. All right, so the last one we have for this note sheet, please pause the video, try it on your own, see what you come up with. If you make mistakes, that's fine. If you get lost at a certain point, that's fine. Do as much as you can based on what we've already done, and then come back and we'll show you what hopefully where you got stuck and maybe how to fix it and all that other stuff. Okay, so take a moment, pause the video, and then come back. All right, so hopefully you've done this problem. You've paused the video, you're coming back for more. And now we can figure out what these pieces are. So the x-intercept, again, you take the numerators. You got 2 minus 2 times the denominator x plus 3. Set it equal to 0. So we have 2 minus 2x minus 6 equals 0. I'm going to add 6 and subtract 2, which gives me 4. So I have negative 2x equals 4, and divide by negative 2. X equals negative 2. I'll write that as a point, negative 2 comma 0. Your y-intercept, 2 over 0 plus 3 minus 2. So I have 2 divided by 3 minus 2 gives me negative 4 over 3. Write that as a point, 0 comma negative 4 over 3. All right, now let's go ahead and graph both of those. I get negative 2 and negative 4/3. So negative 4/3 is negative 1 1/3, so it's about there. It's close enough. Okay, next, your vertical asymptote. Take the denominator x plus 3, set it equal to 0, and solve for x. X equals negative 3. Horizontal asymptote. The only part that I really care about this, as we get better and better at these, is the vertical shift. So y equals negative 2. All right, so let's graph both of those. X equals negative 3, which is going to be here. And y equals negative 2, which is going to be here. Okay, so now we can kind of sketch our graph. It's going to go through these 2 points. Look like that. And over here. All right, and then finally the domain and range. Domain is the x value, so it starts at negative infinity, goes till we hit the vertical asymptote at negative 3, jumps over the vertical asymptote, and continues on towards infinity. The range, the y values that exist, negative infinity to the horizontal asymptote at negative 2, jumps over, and continues on towards infinity. That's it. Okay, now, it is really extremely important that if you're going to do these well, you have to practice these. These are something a little bit different. It's going to take some time for your brain to get around it and to remember what to do for each piece, okay? So please do so. Practice this, ask questions, get help, okay? All right, good luck on taking the practice, and we'll see you.